Welcome to lesson 9-1. We are going to be factoring trinomials in 9-1. We're going to be looking at trinomials in the form of x squared plus bx plus c. Okay? So we also call those quadratic expressions. Okay, so we want to factor the quadratic expressions of the form x squared plus bx plus c as the product of two linear expressions, and they'll be two linear binomials. So recall from activity 8 where we had this factor steel building, and we also know from working with the algebra tile examples how we can represent the area of the entire office building as a sum of all the areas. So if you remember x by x, the big tile is x squared, and the next size tiles are x by 1, so they're each x, and then of course the smaller cubicles are representing by 1 unit. And so if we add all those up, we actually have x squared, we have 5x tiles, and then we have plus 6 of the individual units. Now that's the quadratic expression because it has an x squared. The area of the entire office as a product of two binomials or two linear expressions can be found by looking at the width and the length. So the width could be represented by x plus 2, that would be the side, and then the length would be x plus 3. Okay, so if we write those out as a product of two binomials, x plus 2 times x plus 3, we should be able to FOIL to show that they are the same. So if I do x times x, I get x squared, and then we have 3x plus 2x, and then plus 6 for the last. So it's x squared plus 5x plus 6. So items 1 through 3 show how to use algebra tiles to factor a quadratic expression. However, drawing tiles to factor quadratic expressions can become time-consuming. So we're going to look at some patterns instead. Factoring a quadratic expression of the form x squared plus bx plus c as the product of two linear expressions can also be described as factoring a trinomial into two binomials. Okay? And we've already done a little bit of this. In lesson 8.2, we looked at special trinomials, the perfect square trinomials. So now our trinomials aren't going to be special. They're not going to necessarily have two identical binomial factors. So consider the linear expressions x minus 5 and x plus 3. If we were to determine their product, we can do that pretty quickly by using FOIL. So x times x is x squared. And then the outer's 3x, the inner's minus 5x, and the last negative 15. Then we will get x squared minus 2x minus 15. Okay, so that is not considered a perfect square trinomial because its factors are not identical. Okay, so the coefficient of the quadratic expression's middle term is related to the constant terms of the linear expression. So that negative 2 is equal to negative 5 plus 3. So it's the sum of the constant terms. Okay. How is the constant term of the quadratic expression related to the constant terms of the linear expression? Well, the constant term of the quadratic expression is negative 15, and it is equal to the product of the constant terms, that negative 5 times negative 3, or times 3. So if we do the same thing with number 5, it says consider this expression, and we want to again find the product. So if I do x times x, again, I get x squared, and then 1x plus 6x, that's 7x, and then 6 times 1 is 6. So let's look and see if the same pattern holds true. Okay, notice that the middle term 7 is equal to 6 plus 1, and the constant term 6 is equal to 6 times 1. So the pattern does hold true. So in our expression, ax squared plus bx plus c, b, the coefficient of the middle term, is the sum of the constants. whereas C is the product of the constants. Okay, so that pattern is going to help us learn how to factor. So on the next page, we have a trinomial, and it's an example of using a box to do your factoring. And we won't do this very often, but it's good to look at one of these. It's a graphic organizer, and we know that the first term is x squared, and the last term is 32. And what we want to do is identify some factors of C that add to B. So if we look at our little table, we can see factors of 32 include 32 times 1. But 32 plus 1 is 33, and we want to add to 12. 16 times 2 is 32, but 16 plus 2 is, again, not 12. So finally, we figure out it's 8 and 4. 8 and 4 multiply to 32, and they also add to 12. So that ends up becoming the winning combination. And so the 8x and the 4x can go in the box. And now we can see that the width would be x plus 8, and the length is x plus 8, and the width is x plus 4, and that's one way to factor your expression. Okay, but we won't really be drawing boxes very often. We can try one and see how it goes. So let's look at this one. So it says fill in the missing sections of the graphic organizer for the quadratic expression x squared minus 6x plus 8. Okay, so let's look and see. If we have to multiply to 8, but add to negative 6, then we know that if we have we have to multiply to positive, but add to negative, they're both going to have to be negative. And so we're going to end up using, they already gave us negative 4x, this is going to have to be negative 2x. And then we'll be able to multiply then to 8 and add to negative 6. So we get across the top, we get x minus 2. And then on the bottom, we're going to get x minus 4. And so we'll have our answer of x minus 2 times x minus 4. We can check it with FOIL. We can see we get x squared minus 4x minus 2x plus 8. So we do get x squared minus 6x plus 8. And so that's our answer. Okay, so when we make one now, we're going to try to make one by using x squared plus 14x plus 45. We'll try that trinomial. So let's make our box. I'm going to put it down a little bit so that I have room to write above it. There we go. All right. So in our first corner, we have our x squared. Okay, so we know that's going to be x times x. And in our bottom corner, we have our 45. And now we have to think about our factors of 45. So we want two numbers that are going to multiply to 45, but add to the middle term, which is 14. So then we have to think about two numbers that multiply to 45 and add to 14. And hopefully you see that they are going to be 9 and 5. So then we'll put a 5x here and a 9x here. And that means it's x plus 5 and x plus 9. And that is those are our factors. So x plus 5 times x plus 9 would FOIL back into x squared plus 14x plus 45. So we don't really need a box to do that. Instead, we're just going to use that multiply add trick for these. So for part C, let's go ahead and try it. I'm going to just set up some parentheses, because I know I need to use FOIL to check. Okay, my first times my first term has to multiply to x squared. So that has to be x times x. Now my last times my last has to multiply to negative 27. So I want to multiply to negative 27, but I want to add to positive 6. So I think about those numbers, and I come up with 9 times 3 is 27. 9 times negative 3 is negative 27. And 9 plus 3 is 6. So it needs to be plus 9 and minus 3. Okay, and you can definitely get a 6 in the middle if you do 9x take away 3x. Okay, let's try part D. So part D, I start making my parentheses, and I have an x and an x to make x squared. Well, now I need two numbers that multiply to 1 but add to 10. Multiply to 1 but add to 10. Those numbers do not exist. So this polynomial cannot be factored. And so when a polynomial cannot be factored, we are going to call it unfactorable or prime. And that's what this math tip box over here says. So we say unfactorable and we also call it prime. All right, we are going to do some practice now. So in the Check Your Understanding, I'll work on these now in the video, and then we'll save the practice for the classwork. So our very first polynomial in the Check Your Understanding, we're going to set up our parentheses, and we know now that we need x and x, and now we need two numbers that multiply to 56, but add to 15. So multiply to 56, a lot of numbers that'll multiply to 56, but add to 15. And so we come up with 8 and 7, and it works. Okay, then we'll try two numbers that multiply to 120, add to 22. Multiply to 120, add to 22. And then I think of 10 and 2. So x plus and x plus, and we get 10 and 12. So 12x plus 10x is 22, x for the middle, and 10 times 12 is 120. Okay, so let's try the next one. Next one has some minus signs in there, so we want to be careful with those. So let's open up our quantities. So you want to multiply to negative 27, but add to negative 6. Okay, so this is similar to one we worked on a little earlier. So negative 9 and positive 3. So x minus 9 and x plus 3. Okay, next I want to look at x squared minus 14x plus 48. And so I need two numbers that multiply to 48 and add to negative 14. Okay, so I'm going to try, 12 and 4. So 12 times 4, yes, they multiply to 48. They do not add to negative 14. And even if I changed their signs to both negative, they still multiply to 48, but now they add to negative 16. So 12 and 4 are not good numbers to pick. So I'm going to pick something different. Maybe try 6 and 8. So 6 and 8 multiply to 48, but they add to positive 14. So I'm going to try negative 6 and negative 8, and they do add to negative 14. So x minus 6 times x minus 8. And for number 11, we want two numbers that multiply to 1 and add to negative 1. Multiply to 1, add to negative 1. Those factors do not exist. So we would say unfactorable or prime. So the lesson practice is yours to try. We'll also do some of those in class.